Hey everyone, welcome back to the channel. Today, we're diving into an incredible cosmic mystery that's been boggling scientists for years, and it all kicks off with a trip to the moon. Picture this. It's 1970, and astronauts from the Apollo missions are hauling rocks back from the lunar surface. When scientists start analyzing these samples, they uncover something mind-blowing. Evidence that these rocks were slammed by asteroids or comets about 3.8 billion years ago. Now for the moon, that's pretty standard stuff. It's been a punching bag for space debris forever. But here's where things get wild. That initial excitement turned to jaw-dropping awe when they checked out Mars and found the exact same thing. Craters showing asteroids had rained down like bombs around the same time. And it doesn't stop there. Imagery analysis of Mercury revealed craters formed by asteroids that smashed into it 3.8 billion years ago too. Even Earth and Venus show signs of this same phenomenon. What's weird about this? Well, these celestial bodies were just babies back then, having formed only a few million years earlier. So, why did all these inner solar system objects get hit with missile-like asteroids at the same exact moment? It's almost like the whole solar system was caught in some cosmic war. But the big question is, was there some ancient civilization out there turning our solar system into their battleground? Or is there a more scientific explanation for this asteroid bombardment? Let's find out. To get to the bottom of this, we need to rewind to how our solar system came to be. Scientists rely on traditional models like the minimum mass solar nebula model, which says all planets formed from the same swirling cloud of gas and dust around the young sun. The outer planets, being super far from the sun, stayed chilly enough to grab light gaseous molecules like methane, ammonia, and carbon dioxide, condensing them fast and growing massive. Take Jupiter, for example. It's the farthest out of the inner planets league, so it scooped up lighter elements like hydrogen and helium first, ballooning into the giant we know today. As it formed, the solar nebula, the gas and dust cloud that birthed our solar system, started running out of material. Eventually, all the planets stopped growing, their sizes locked in with barely any change, leaving Jupiter as a failed star that didn't quite have the mass to ignite. On the flip side, planets closer to the sun couldn't condense those gases on a big scale or as quickly, so the closer a planet was to the sun, the more solid, rocky, and smaller it stayed. As you move out from the sun, planet sizes generally get bigger up to Jupiter, then taper off after that because the outer planets beyond Jupiter, like Saturn, Uranus, and Neptune, had to make do with whatever scraps of the nebula were left. This model holds up pretty darn well, almost like it's bulletproof, until you throw Mars into the mix. If we peek at NASA's official numbers, planet sizes increase from Mercury to Earth, but then Mars breaks the pattern. It's not just smaller than Earth, it's even tinier than Venus, despite being farther from the sun than Earth. That's an anomaly that doesn't fit the mold. Why? Well, it turns out that about 3.9 billion years ago, Mars, along with the entire inner solar system, got hammered by a storm of asteroids in what's called the Late Heavy Bombardment. The craters from that event are still etched into the surfaces of these planets and moons today. Here's the kicker. This kind of chaos couldn't have happened without some external trigger. Planetary positions haven't shifted much in billions of years, so if this bombardment was just a regular thing, we'd see it repeat over time. But it didn't. Something big went down 3.9 billion years ago that flipped the solar system's future upside down. This mystery sparked a hunt for answers, and one day, NASA scientists John Chambers and Jack Lissauer were eyeballing the solar system's planetary orbits when they spotted something odd. There's this massive gap between Mars and Jupiter, big enough that a full-on terrestrial planet could squeeze in there between Mars and the asteroid belt. That got them thinking, what if way back in the past, there really was a planet there that's now gone? To test this wild idea, they fired up computer simulations of the early solar system, but with a twist. Instead of the usual 4 inner planets, they added a 5th one, dubbed Planet Vi. They slotted it between Mars and the asteroid belt, about 1.9 astronomical units from the Sun, and tweaked its mass to around a quarter of Mars's. After some trial and error to nail down the parameters, they ran the simulations to see if this setup could match our solar system's current state and solve all those weird incidents tied to this missing piece. After testing a bunch of variations, John and Jack hit on a model where 5 inner planets could coexist with the rest of the solar system, and Planet 5 fit like a glove, at first. With a mass of about 4.25 times Mars's, it aligned perfectly, but only if they kept it at that sweet spot, too light or too heavy, and the solar system's present didn't look right. Here's the catch. While Planet 5 orbited fine for a while, after a few million years, its orbit went haywire. The gravitational tug from the 4 inner planets, Mercury, Venus, Earth, and Mars, started messing with it, either pushing it toward destruction or flinging it out of the solar system entirely. In 2007, Chambers published results from 96 simulations in the journal Icarus, showing that over 600 million years, the inner planet's gravity warped Planet V's orbit. Since it was so lightweight, it couldn't hold its ground, and the inner planet's physics made it inevitable that it get shoved outward, stretching its orbit into a wild, eccentric ellipse. Now, let's talk orbits for a sec. A circular orbit is stable and predictable, meaning a planet's path is fixed with little risk of crashing into stuff. The more elliptical, or eccentric, an orbit gets, the more chaotic it becomes, upping the odds of collisions. In our solar system, aside from Mercury's slightly wonky orbit, everyone plays nice with near-circular paths that don't cross. But in Planet Void-Seedena simulations, Mars and the other inner planets nudged it toward the asteroid belt, making its orbit super eccentric and unstable. After millions of years of this instability, around 3.8 billion years ago, Planet Vive couldn't take it anymore. So, what happened next? The simulations offer 3 possibilities. First up, Planet 5 drifts outward and plows straight into the asteroid belt. The moment it barges in, it scatters tons of asteroids toward the inner solar system, kicking off that 3.8 billion-year-old asteroid rain we see in the craters on all the major planets and moons. The proof's still there today, time-stamped to that exact period when Planet 5 disrupted the asteroid belt structure. After stirring up that mess, its orbit got so distorted that it was booted out of the solar system, turning into a rogue planet drifting through space. Second option, it's pretty similar. Planet 5 crashes into the asteroid belt, sends asteroids flying inward to start the late heavy bombardment, but instead of escaping, it slowly gets pulled toward the sun's gravitational grip and eventually plunges into it, gone for good. Both scenarios explain a lot, but they still leave Mars's oddly small size a puzzle. Why didn't it grow like the models predict? That's where the third possibility swoops in, tying up loose ends like a champ. In some simulations, Planet Vive doesn't make it to the asteroid belt. Instead, it slams into the closest inner planet, Mars. Here's how it might have gone down. Around 3.8 billion years ago, Mars was likely bigger than Earth, following the solar system's growth models. Then orbital instability hits, and Planet Vive collides with it. The impact sends debris flying, pelting the inner solar system and creating those late heavy bombardment craters. Now, if a collision that massive happened on a lively planet like Mars way back then, there'd be evidence, like a giant crater. Scientists studying Mars's huge craters zeroed in on the Borealis Basin, which spans almost 40% of the planet's surface. Sure, natural factors could have made it, but if an external culprit's to blame, it'd have to be something planet-sized, like Planet 5. Researchers strongly suspect this basin marks that epic crash, making this hypothesis a perfect fit to unravel the early solar system's mysteries. Oh, and get this, the asteroid that brought water to Earth? It hit around 3.8 billion years ago too, right during this bombardment. That hints Planet 5 might have had water reserves, and maybe even life. So, what do you think? Could there have been an alien civilization on that planet that either got wiped out in the chaos or bailed to survive somewhere else? Drop your thoughts in the comments below. I'd love to hear what you've got to say. All right, folks. I hope you learned something new today. If you did, smash that like button and share this video with your friends. New to the channel? Hit subscribe and turn on notifications so you don't miss out. If you like this, I recommend checking out our next video where we tackle whether it'd be tougher for humans to live in the Sahara Desert or Antarctica. What's your guess? Let me know in the comments, and if you're curious, go watch it. Catch you in the next episode. Until then, take care.